In this video, I'm going to be upgrading the RAM on and repairing this mid-2012 11-inch MacBook Air. Now, if you watched my last video, you would know that I did this exact same upgrade, basically, on a first-generation MacBook Air. Well, technically a second-generation, I guess you could say, but it is still the same chassis and case and whatnot. But I upgraded it from its original 2 gigabytes of RAM to 4 gigabytes of RAM, which was something that was never offered by Apple. They were only offered in 2 gigabyte RAM configurations. Now, in the case of this machine, this is a mid-2012, which was offered in both 4 and 8 gigabyte configurations. However, in this video, I'm going to be upgrading it to 16 gigabytes, which never was an option on any MacBook Air as far as I'm aware. It may have been an option on the very last ones, but I'm not 100% sure on that. I do know that at least the 2014 and older models never came with more than 8 gigs of RAM from the factory. So in order to perform this upgrade, we're going to be using these SODIMMs right here, just like we did in the last video. However, these SODIMMs are both 8 gigabytes in size and are the correct configuration for this particular board. So the board has 16 chips, each of these memory modules has 8 chips, and the board emulates 2 individual modules. So this will work exactly as intended. Now, in addition to upgrading the RAM on this machine, we're actually going to be repairing this machine. And the reason I say that is because this machine actually has an issue, which I'll go ahead and show you right now. Go ahead and turn it on here. And you can see that it does not boot up, but rather just gives the 3-beep RAM error code. And that, of course, indicates that the internal memory on this machine has some sort of issue. So one of the chips has probably failed, or in some cases, I think it might be a soldering issue, but regardless, in this video, we're just going to be replacing all the chips with these larger chips from these SODIMM modules, and of course, in the process, upgrading the RAM to 16 gigabytes. So with that, we'll go ahead and begin the process of upgrading the RAM in this machine. So the first thing we're going to need to do in order to do that is to desolder all 8 chips from each of these memory modules, and then once we do that, we can reball them and prepare them to be installed in the machine. So I'll go ahead and get my reballing or my desoldering setup ready for these SODIMM modules and begin removing the chips. Alright, so as you can see here, I've gotten the first SODIMM module up here on the board preheater. So of course, let's just go ahead and heat it up and start removing the chips. So the first thing, of course, we're going to do is just remove these stickers once it gets a little bit of heat into it. Just like so. And now with those removed, we can go ahead and start removing the chips. First step, of course, is to apply some flux to each one. And now that the hot air is up to temperature, we can go ahead and start removing the chips. Alright, and now that all of the memory chips have been removed from both modules, now we need to just go ahead and prepare to reball them. So we'll just have to go through, clean all of the residual solder off, and then we can go ahead and reball the chips. So with that, I'm going to go ahead and get the platform in view here where we can clean all the chips off, and then I'll go ahead and resume the video. Alright, so now with all the chips in position, we can go ahead and remove all of the residual solder. Alright, so now with all the residual solder removed, we can go ahead and wick each of the chips to remove everything else. Alright, so as you can see there, all the chips have been fully wicked, so there's no more solder on any of the pads. So now what we're going to do is just get my reballing jig out and begin the process of reballing each of these 16 chips. Alright, so I've gone ahead and cleaned all the chips off with a bowl of rubbing alcohol, which you can see right here. And as you can see, they look absolutely perfect, so there's no issues, and they are perfectly clean with no burnt flux on them. So with that, we're just going to go ahead and get started with the reballing process. Of course, the first thing we need to do is just insert them into their stencil here. So, like I mentioned in the last video, I am lucky to have this stencil, which I can use to actually do 4 chips at once, which definitely saves a lot of time as opposed to doing them one at a time. So of course the first thing we need to do is just put this stencil in, which holds each individual chip in place. We need to just apply each chip in their section. And then put the main BGA stencil over top of them. Just like that. And you can see that all the holes line up perfectly on there. So that is perfect for reballing, of course. So once they're all in, you can just slap it on the magnetic base, and that holds the stencil down and keeps pressure on top of the chips. So with that, we'll go ahead and get the correct size solder balls out. In the case of these chips, they use 0.45 millimeter balls, which is printed in the bottom of the stencil here. So we'll just find some 0.45 millimeter solder balls here. There they are. And then we'll just go through and reball each chip. Now, another thing I did mention in the last video is that normally I apply flux to the chips before applying solder balls, but in the case of these small memory chips, I found that it works perfectly fine to apply the balls first with everything dry, and then use the flux to seat the balls fully once the heating is complete. So we're going to go ahead and just start by applying these solder balls to the stencil. And I found that when getting all the balls in the holes, you can actually just use your finger and just rub them around like this. And as you can see, they're pretty much all in their holes. You will get a few extras, but just go across every now and again, and you probably won't even have to use tweezers to do it. So I'm just going to keep doing that on each one here. Now that one has a ball in every hole. That one has a ball in every hole now. And so does that one. So that is the easiest way I found to do this reballing. So then with this stencil, you can actually collect all of the residual balls and put them back into the holder. So it's got a little spout on it which contains all the balls, and then you just put them right back in, just like so. Now I did notice that 2 balls on this one fell out of their holes, so I'm just going to apply a little bit more and do it once more. There we go. So now we've gotten a ball in every single hole on this stencil. So now what we can do is just turn the hot air on and begin heating these solder balls. Alright, and then once all these solder balls look to be melted, just give them a time to cool down, and then we're just going to apply a thin layer of flux to each one. So of course you want to make sure all the balls are solid before you do this, otherwise you'll mess them up. So they look pretty good now, so we'll just go ahead and apply flux. And then once the flux is applied, you're just going to want to go over with them one more time and heat them until all the balls fully seat into their holes. Alright, and then once all of these solder balls cool down just a little bit, you can go ahead and remove them from the stencil. Alright, so now that we've gotten 4 done, you can see that all the balls are now on their respective pads and everything looks good. Now what you want to do is just go through them one more time and just heat them for the final, to ensure all of the solder balls are fully seated onto their pads. Alright, so now all those chips have been fully and successfully reballed. So now we just need to repeat the process for the other chips. So 3 more times with 4 chips each, of course. And then once that's done, we'll be able to install them onto the MacBook Air logic board. Alrighty, so as you can see here, all of the chips have been successfully reballed. You can go ahead and take a look at them and see that all the balls are completely uniform and there are no missing, and it all looks perfectly even as it should. So we are now ready to begin the process of desoldering the chips on the MacBook Air logic board and then soldering these chips on. So with that, I'm going to go ahead and get the board preheater up to temperature with the MacBook Air logic board on it, and then we'll go ahead and remove all of the original RAM chips. Alright, so as you can see here, I've gotten the board and the board preheater, and luckily on this board, all of the memory chips are on the same side, so that'll make it a little bit easier to do. So you can see all 16 are right here, so I'm just going to go ahead and go through them and remove each one. Now, of course, before I do that, I've got to apply some flux to each. And with that applied, we are now ready to begin the process of removing each chip. Alrighty, so now that all the chips have been removed, we're just going to go through all the pads with the soldering iron and some solder wick and remove all of the residual solder. Alrighty, and now that all of the chips or all of the pads have been wicked, now we'll just go over them with a paper towel with some rubbing alcohol to clean off all of the residual flux. Alright, so now that all the pads have been perfectly cleaned, now we'll just go over them again with some new flux, and from there we can begin the process of soldering the new chips on. Alright, so that was a bit of a pain to align, mainly because there's no silkscreen outline around each chip, as you can see. But now, let's just go ahead and wait for the board preheater to warm back up again, because I did turn it off so I wouldn't burn myself while I was doing all that aligning. But they all look good now. They're in their general location. As long as you get them close enough, they'll be just fine. They'll kind of just seat into place once the balls melt, so I'm not too worried about it. Like I said, as long as it's in the general location and all the spacing and everything looks just fine, so I'm not too worried about it. So with that, let's go ahead and get the board preheater warming up, which it already is, get the hot air turned on, and then we'll begin the process of simply soldering these chips back onto the board. Alright, so all the chips look to have been soldered on successfully. I was able to see quite a few of them move down into place. So now we'll just let the board cool down, hook it up to the machine, and give it a quick test. Now, I don't really expect it to actually boot or anything, just like the 2009 machine we did before. But hopefully it'll at least do the 3 beeps or 1 beep or something, so we know we didn't hurt anything any more than it did. So we'll go ahead and let this cool down and then go from there. Alright, so before I put everything back together, now that the board's cooled down, I just wanted to show you all of the chips on here. So if you go ahead and take a look, you can see that all the solder balls are completely even, at least on the edge here, and the chips are completely flush with each other, both horizontally and diagonally, if we can, or horizontally and vertically rather. So you can see that they all look good. I did verify, and pin 1 is in this top corner of every single chip. Of course, I did verify that with the schematic. You can see that every chip is in that correct orientation. So with that, we'll go ahead and put the board back in the chassis and see what it does. Like I said, I don't really expect it to do much, other than what it really did before, where it would just 3 beep, or it might even 1 beep. I have seen that before as well. So I'll just go ahead and get this in the machine, test it, and then we'll begin the process of modifying the SPD info in the system's SPI ROM, just as we did with the other machine. Alright, so as you can see, I've gone ahead and installed the board into the machine and plugged everything in, including the left I/O board and everything. So let's go ahead and plug in the power and see what it does. So it turned on. Okay, and as suspected, we get the 3 RAM beep error. So now what we need to do is just desolder the SPI ROM, dump it, and modify the SPD definitions in it. Alright, so I've now gotten the board prepared to desolder the SPI ROM. So as you can see, the SPI ROM is located right here. I'm going to go ahead and turn on the board preheater, get the board warming up, and we'll go ahead and remove the chip. First thing to do, of course, is apply some flux. And now we can go ahead and remove it. Alright, so as you can see there, we've gotten the SPI ROM removed. So now I'm going to go ahead and just clean it off, and we'll get it into the EEPROM programmer. Alright, so now that the chip has been cleaned, we can go ahead and put it in my little EEPROM programming adapter here. So let me go ahead and get this straight here. Alright, all you do is put the chip in with pin 1 towards this corner, and close the little lid here. Alright, and now that that's in, we'll just take the little adapter here and put it into the EEPROM programmer. Next thing we need to do is head on over to the programming software here, and we need to select the IC. So we'll just go select ICs, 25 flash detect, select detect. And I guess it's in backwards, so let me fix that real quick. Alright, so I just had the chip in backwards in that little adapter, so we'll go ahead and select detect. As you can see, it detected the chip, and it's going to be this one right here, the N25QO64A. We'll select select, and then we'll go ahead and read the chip. Alright, and as you can see, the chip was read successfully, so we'll go ahead and save that. I'll just save it as MBA. I forget which model this is. I think it's a 7 something, I don't know. I'll just say MBA 2012 original Okay, so now we have our original ROM saved. So now, of course, what we're going to do is go ahead and open that ROM in UEFI tool. Open it here. Okay, so with that, we'll go ahead and open image file. We will select the MacBook Air 2012 original right there. And as you can see, the image was loaded. And now what we can do is select search in the file menu here. And from there, we need to search for the pattern or the sequence of bytes corresponding to an SPD entry. So in order to do that, I just got the SPD info that I dumped from that SODIMM that I showed you earlier that we took the chips off of. And this data is actually what I will be using to tell the machine exactly what type of memory is installed. That is the purpose of the SPD, or serial presence detect info. In the case of SODIMMs, of course, the info is on an EEPROM on the card or on the module itself. But on machines like this with the memory soldered on, the SPD info is actually located in the system's ROM. Now, in the case of this machine, since it had two memory configurations from the factory, 2 gigabytes or 4 gigabytes, there are actually, 4 gigabytes or 8 gigabytes, there are actually resistors on the board that you can set to tell it which piece of SPD data to use in the system's ROM. So it actually has a routine that checks some GPIO pins on the PCH, and that, and the state of those, either high or low, tells it which set of SPD info to actually use to run the system. But in this case, since 16 gigabytes was never a supported memory configuration on the 2012 MacBook Air, we will have to add that info, and in order to do that, the easiest thing to do is simply use that SODIMM, that 8 gigabyte SODIMM, to tell the machine that it has two 8 gigabyte SODIMMs of that specification. So let's go ahead and get these first 4 bytes here. And I mentioned in the last video there's a table you can look up. So if you're interested in going to look at that table, you can check that video out, or just Google for DDR3 SPD table, and you'll find what all these bytes actually mean. But for now, let's go ahead and just copy those, go into UEFI tool, paste, and see if we can locate it this way. So as you can see, there are a few entries right here. So we'll go ahead and find that here. Now I want to check each one and see where they are. So you can see that there's one in here, there's one in that raw section, and let's see, is that the same raw section? Oops. D357, yeah. So it seems to be 2 in either section, which is exactly how the other one was, so that's what I'd expect. Alright, so we'll go ahead and right click on this, select extract body, and we're just going to name it raw1.bin. And the second one, we'll just extract that. raw2.bin. And I believe these are in the same section. Let me just verify that. Okay, so there's actually 2 more raw sections at the bottom here, which contain more SPD info, which is interesting. So we'll go ahead and extract this body. raw3.bin. And this last one right here. raw4.bin. And now that we've gotten all those extracted, we're going to want to open each one in a hex editor. So let me do that real quick. Alright, so this is interesting. It looks like each of these has an SPD dump in it. Now, there should be more than just this, so I'm going to go back and check. Let's go to that table real quick, and I'll show you what one of the bytes means. It's just a version number. There's a few choices where what it could be, so we might be able to find more SPD info by changing that. So I'll go ahead and open that and show you what we're going to check. Alright, so I've gone ahead and opened that web page that I showed you earlier. So this is what we're going to search here. So right now, the one we were searching for, of course, has a revision of 1. You can see 9210 there. And in here, you should see the first thing should be 92, and then it could be either 00, 05, 10, 11, or 12. So I'm going to search that same string, but just replace this number, and see if we can locate any more SPD info in the system ROM. So instead of 10, we'll start with 00, just to see. So nothing found there. We'll search for whatever the next one is here. 05. Nothing there. We already know 10, so we'll try 11 and 12. Okay, so we found quite a bit more in here, so hopefully we won't have to extract too much here. Okay, so it looks like the best option for this particular ROM is just to extract this entire thing, because it looks like there's quite a few SPD entries in here. So we're just going to go ahead and extract this body, which will include everything. So I'm going to name that, I don't know, ext1.bin, just so we know. And that was these, which are all in the same section here. Those are in the bottom section. Okay, so they're all in the same sections here, so that's good. So we already extracted this one, and now let's extract this one right here. ext2.bin. And that should contain all the SPD info we need. So let me go ahead and just close out of all these. And we'll go and open both of those files we just extracted. So here's ext1. And yep, as you can see, there's quite a bit of SPD info in here. And we'll open the second one, ext2. So there we go. We have quite a bit of SPD info in these. So what we're going to do is, since just like on the last one, I can probably figure out which entry it's using, but just to be safe, I'm just going to replace all of them with the dump taken from the SODIMM module, just to be safe. Like I said, I'm not going to really be modifying this any further once this is done, so I don't see any reason to just not copy all these and replace all of them. So let's go ahead and just find our first entry here. So here it is right here. There's our first entry of SPD info. And it looks like, in this case, we want to figure out how many bytes they're actually really using. And it looks like they're using up to around here, or we could potentially just copy the entire thing, but I don't really see a point in that. Let's see down there. Well, let's just take what we think they're using, so this much, and just paste it in and see what we're overwriting. Okay, and that looks correct. So what you need to know here is that this part of the SPD info, really just from here to here, is what's actually telling it the specifications of the chips you installed. So this extra part is literally just manufacturing info, which doesn't matter. All that's going to do is show in like system profile or whatnot, but it won't really affect the way the system works, of course. So that looks like a correct amount to copy. So we're just going to go through and overwrite each of these SPD entries with that specific info. Let's see, there's more there. Okay, and that's all the entries for that first section. So let's go to the second section here and do the same thing again. Alright, that's done. Alright, so now once you've edited both of those sections, we need to head back to UEFI tool. Go ahead and find the first section here, right click on it, select replace body, and then you're just going to want to select the files you just edited. So in this case, it's ext1 for the first section, which you can see it says remove and replace. And we need to find that second section, which is right here. And we're just going to right click, once again, replace body, select ext2, and you can see that says remove and replace, and then we'll just do file, save image file, and we'll just name it NBA 2012, and we'll say modded. .bin right there. We'll just go ahead and save that, and you can tell it yes, you want to open the reconstructed file. It'll just reload it, and now just head back over to the EEPROM programmer, select load in our NBA 2012 modded right there, and once that's done, select program, and then of course program the chip. So now we'll just wait till that finishes programming, solder it back on, and see if the system will boot. Alrighty, so as you can see here, I've gotten the board reinstalled. I've gotten the SPI ROM soldered back on it. So now let's just go ahead and plug it in and see if it works. Alright, fan spinning. And we got a chime, and the display is on. The machine is now running with 16 gigabytes of memory installed. So that SPD info modification was successful. Like I said, I just took that from the actual SODIMM module that I used the chips from. And I actually will put a link to the dump I took of that SPD EEPROM on that SODIMM module in a link in the video description if you ever want to try this yourself and use it. So with that, and there you can see we have a flashing question mark, so everything seems to be working as normal. So now I'm just going to reassemble the rest of the system, get an SSD installed with an operating system on it, and see if it boots. Alright, I've gone ahead and installed an SSD, so let's go ahead and power the machine on and boot into macOS. Alright, go ahead and log in here, and we'll take a look at the system information. So let's go ahead into About This Mac, and there it is. Look at that. As you can see there, we have 16 gigabytes of 1600 megahertz DDR3 installed. Let's go ahead and check out more info in here. Let's head over to the memory tab. And look at that. You can see that it detects two 8 gigabyte modules installed. Of course, they are virtual modules, like I mentioned earlier. But yeah, there it is. Everything is detected and working properly. So that has been the successful RAM upgrade from 4 gigabytes to 16 gigabytes of memory. And of course, in addition to that, we repaired the machine of this mid-2012 Apple MacBook Air. Now, with all that done, having done this multiple times now, I think I'm confident enough to actually offer this as a mail-in service. So if you want to send your machine in, it can be any Intel Mac with soldered memory for a memory upgrade. I can definitely take care of that for you. And in fact, the newer models, the 2013 and later, only have 4 memory chips to work with, so it's actually even easier than doing it on one of these systems. So yeah, if you want to send the machine in, I'll have information down in the video description that you can look at. If you want to send your MacBook, whether it's a Retina MacBook Pro or MacBook Air or whatever soldered memory machine you have for a memory upgrade, you can definitely do so, and I'd be happy to take care of it. So with that, that has been the successful repair and memory upgrade of this mid-2012 Apple MacBook Air. Hope you enjoyed this video.